Sir, chief guest vantaru. So we'll wait for 30 participants, sir. Then we'll start, sir.
Okay.
Okay, sir. Okay.
நான் இப்போ உங்கள்கிட்ட சொல்றது எல்லாமே நான் வேலைக்கிட்டேன்.
இல்ல.
மாதேஷ்
சார்
கண்ணா
சார் கேக்குதுங்க சார்.
கேக்குது ஆடிபிள் மாதேஷ். கண்ணா ஸ்டார்ட் பண்றது இப்போ
அவங்க தான் ஸ்டார்ட் பண்ணுவாங்க.
ஆமா அவங்க தான் ஸ்டார்ட் பண்ணுவாங்க.
ஆமாங்க.
நான் அட்டல் லெஃப்ட் இருக்கிற மாதிரி நினைச்சிட்டேன். சரி
மகேஷ்.
கண்ணு. ஆ?
சரி சரி
Okay.
Senthil sir, good evening sir. So Chairman sir, shall we start sir?
Madam,
All ready means we will start, madam. Yes. We will start, madam. Yes.
Okay sir. A very pleasure to welcome you all for the Energy Conservation Week celebration 2022 in line with the National Energy Conservation Day celebration on 14th December 2022. Now we have in the technical talk on innovative practices in energy management organized by IEA Salem Local Center in association with the School of Energy and Environmental Science, Periyar University, Salem. Now, I would like to invite our IEA Chairman, Sir, Engineer S.R. Saravanan, to welcome the gathering. Please, sir.
Thank you, madam. Respected speaker of today's program and inauguration, Dr. V. Sivakrishna Rao, Assistant Professor from NIT Trichy, Engineer Sedil Kumar, Dr. Madheshwaran, and other professors from Periyar University, program coordinators, Dr. Davamani Madam, Dr. Tangaraju, the committee members of IEA Salem Local Center, my dear members, and other participants. Yeah, very good evening to all of you. Today, we all have gathered to inaugurate the week-long celebration by IEA Salem Local Center in view of this Energy Conservation Week in association with our Periyar University. Today, Dr. V. Sri Krishna Rao, Sivakrishna Rao sir is available to talk on the topic innovative practices in energy management. Every year we celebrate this in a fitting manner, and this year also we have decided to inaugurate today and celebrate this program on energy conservation from 8th to 14th of this December 2022. With this, I welcome our guest speaker and all the participants for our program. I need not specifically talk about this energy conservation to our members and other participants because everybody knows its necessity, why we should conserve energy. The demand is always on the higher side. Huge efforts are put to generate each and every unit of energy in the power station side, and cost of the energy is also going on increasing. Everything is done. The energy is produced at the cost of sacrificing the resources available in our side. So in order to preserve, it is very much necessary that we need to conserve this precious energy. With this note, I welcome you all and also our guests, also the members from Periyar University. Welcome once again, and request the members to actively participate and make the program a grand success. Thank you.
Thank you, sir, for your warm welcome. Now, I would request Dr. P. Madheshwaran, Assistant Professor, Department of Energy, Science and Engineering, Periyar University, to introduce our chief guest, Dr. Sivakrishna.
Good evening, sir. Dr. D.V. Sivakrishna Rao completed undergraduation in Electrical and Electronics Engineering at Kagathiya University, Andhra Pradesh State University. He obtained MTech and PhD from National Institute of Technology, Tiruchirappalli. He has teaching experience in prestigious Indian institutes. He's Engineering, Birla Institute of Technology, Misra. He was worked as an assistant professor, senior grade in the School of Electrical Engineering, Vellore Institute of Technology, Vellore. He worked as an assistant professor in the Department of Electrical Engineering at NIT Srinagar. He worked for the establishment of NABL accredited calibration laboratory in NIT Tiruchirappalli. He had an experience in the field of calibration as technical manager. His experience includes solar photovoltaic systems, forecasting techniques, and MPPT techniques. He is currently working in the area of electrical vehicles, smart grid technologies. He has performed consultancies for solar PV plant installation and testing, energy auditing studies of industries, and also include in his consultancy work. He had guided the UG and PG students in the area of energy generation and energy power management in the smart grid. Thank you.
Now I request our chief guest, Dr. Krishna Rao sir, to present the topic.
So very good evening. All of you, am I audible, sir?
Yes, sir, audible, sir.
So first of all, I would like to thank Sir Saravanan inaugurating the event, and thank you very much for humble introduction about me. Today I'll go for my screen sharing. Like I'll directly go to the topic, and once again I will be very much thankful for inviting me for giving this lecture on this topic. I hope can able to my screen now.
Yes.
So can you able to see the presentation now?
Sir. Yes, sir, visible, sir.
Yes, now okay, because now I giving screen sharing option. Fine. So okay, shall I start, right?
Yes, sir, please, sir.
Okay.
Yes, sir, you can start.
Please, sir.
Okay, fine. Okay, next 45 minutes, I'll take concept on innovative practices in energy management. So before I already I mentioned that first of all, Institute of Engineers Salem Center in association with the School of Energy and Environment Science, Perry University, they are celebrating the Energy Conservation Day or the week, Energy Conservation Week, and on behalf of that, it's I get an opportunity to speak a few things about energy management and energy conservation, and maybe within the short notice, I am very much thankful to the team for inviting me. So coming to the topic, innovative practices in energy management. First of all, I'll present my objectives or the contents. First of all, energy management. What is energy management? We are all seeing maybe from at least the graduation level. And what are the energy sources? We are seeing from the school level, what are the different energy sources? And first of all, what is energy conservation, and where the India, now energy conservation happening, what India has taken initiatives for energy conservation, and what are the currently people are moving from now 2020. So what are the innovatives we are seeing in energy management? So really the current society is worried about energy management or not? And what innovative ideas are there are implementing right now from industry point of view as well as in the R&D point of view. And we have taken some case studies from maybe for the NIT Tiruchi campus point of view, we have taken some case studies. First of all, energy conservation to explain to the student level such that how they can practice these things in their day-to-day life. And finally, what actually energy conservation will do, even in terms of cost, because finally we'll talk in terms of cost, even not only cost, we'll in terms of environment also, what energy management can do for energy conservation, and how energy conservation will help for our environment. So these are all the aspects. I'll be briefly going to each and every topic, maybe for five minutes like that. So first of all, coming to the energy conservation. So what is the energy conservation? The topic itself is broad, that what we want to conserve, or first of all, what we are generating and what we are utilizing. So what is energy conservation? Energy conservation topic will be there when there is energy utilization. First of all, if there is no energy utilized, then where is the point of energy conservation? So energy conservation is linked to energy consumption, like how much amount of energy we are consuming, or else how much energy to provide a service. We are getting a service. So to get a service, how much, for example, we are getting electricity at our home. It's a service. So how much energy is consuming completely the product of energy, like I'm saying, electricity you are getting at our home, how much energy we are spending it. So it is like energy consumption to get a product or a service. It is first of all its amount of energy consumption. So similarly, not only that, we are coming to the building also, like how much energy we are consuming to construct a building. Similarly, how much energy you are keeping to make the building, I can say it's a maintenance. It can be heating or cooling, the requirements. I can say completely define the products and services. What are the products, services? They're all will be giving you some user, I can say user defined output, right? So, and that is one thing. And the second thing, energy conservation and energy consumption. So, energy consumption will give you the definition of energy conservation, like how efficiently you have to get our services and products. Like, because you're getting a service and product, whether it is a efficient, energy efficient, or first of all, the meaning is that energy efficient means we should not compromise about the comfort levels. We should not compromise about the services, but still it should be energy efficient. So that is the meaning of energy conservation point of view. And again, because not only that, so we have to try to minimize the energy usage wherever it is possible. We have to minimize the energy utilization without losing the actual comforts. So if you see the point here, like reducing the energy usages is a key solution for reducing greenhouse gas emissions. So this is what our energy conservation, and energy conservation is also, if you go for energy conservation techniques, obviously they will be including your greenhouse gas emission reduction also. So first of all, definition of energy management. So how to do energy conservation with proper energy management. So for example, in the complete lecture, because the same analysis will be applied for industry also, or if you go for a large application also, the same energy management analysis will be applied. For example, if you take energy management, what is energy management? Finally will be contributing to save energy. The thing is that you have to meet the load demand, means you have to 100% load demand. There is no compromise in the load demand. Like whatever the services, like in the terminal will say load demand. The load demand has been met. The energy management, how you are generating your energy, how we are converting the energy from one form to other form, then how we are distributing the energy. Finally, we are taking to the end user, like load. So how we are doing it, how organizedly we are doing it, that is called energy management. So proper energy management, like already mentioned, like it's involved planning as well as operation of energy production, as well as energy distribution and storage also. Like energy production, we do distribution to storage. So if you see some application here, I have taken some domestic application. So for a particular typical application, what is the energy management here? For example, we have a building here. So we have an utility. Utility means we need a source. So here utility means the power supply or the electricity supplier, for example, a company where we are getting electricity, right? That building is getting power from energy storage. The building is getting energy from utility, and the building is getting energy from renewable sources. Like completely, it is having so many appliances, and we are having some going for this. Now I'm saying innovation point of view. So in innovation point of view, we are going with some smart sensors and smart meters. These all will come under some energy management of a building. So these are the typical parts of energy management. And if you take any application where we have a scope or where we have energy consumption, there these are all the things will be the common factors which will be contributing are the management of these appliances, whatever we are saying, components or appliances. For example, utility, smart appliances and smart sensors, smart meters, energy storage. We have to have a proper management such that you have to make your building as an energy efficient building, or I can say your surrounding should be energy efficient, such that you can say it is indirectly contributing to the savings of energy, and you are trying to conserve the energy as much as possible. So coming to the energy conservation in India, so it has the initiation like started in the policy level, and it is moving towards like what energy policy, energy conservation in India. So we are mainly focusing upon decreasing the fossil fuel power generation, because again, energy conservation, if you talk about, whatever the energy we are getting in the form of electrical energy only, direct application is electrical energy only. For example, if you see India now, almost we are having 400 to 450 gigawatt of electricity. We have installed capacity, like we are generating from thermal power plants, we are generating from I can say hydel power plants, and we are generating from natural gas based and oil based power plants. We are all generating almost 400 gigawatt of energy. Out of that 250 gigawatt of energy, what we are getting or what we are generating is for fossil fuel based only. So, and if you see typically that fossil fuel based technology, if you talk about coal power plant, it's almost the efficiency is less than 30%. We can't even get less, more than 30%. So where the remaining 70% is going on, like how much energy we are keeping in, and we have a lot of scope there to conserve the energy or save the energy. So to save the energy or to conserve the energy, instead of like we have to go for energy efficient techniques, and not only that, we have to move to some efficient techniques, or we have to move to some alternative sources of energy like nuclear, solar, and wind. These are all the points. Alternative sources of energy has been included in energy policy of India. So the act has been implemented around 2001. So this is 2001 that act has been implemented. What actually the act says, 2001 act says. So if you see in India, government has passed energy conservation bill 2001 for better utilization of energy and conservation of the same. So this bill speak about, or the Indian policies speak about how better means, here the better means efficient way to utilize the energy and the conserve the energy. And not only that, what are the proper way to efficiently utilize the energy? First of all, to utilize the energy, like I mentioned, we have to manage the energy. Not only that, first of all, you have to audit the energy. Auditing the energy means like how we'll do financial auditing. The same way we have to audit the energy, like what is the power consumption components, like what are the total components, what is the, like we can say energy flow diagram, like from I can say each and every equipment. If you have an industry, like you have to find out the total energy input to the system, and again what are the output out of the system, and finally where the losses are going on. So this is what our energy audit. If you talk about a thermal power plant, we have to talk about energy auditing about the boiler. We'll talk about energy auditing of the furnace, and we'll talk about energy auditing of the turbine. So finally, overall thermal power plant, what is energy auditing? So we have to conduct the energy auditing studies. Then only we'll know complete energy flow diagram, and we'll come to know where actually the losses are, and is there any chance to minimize the losses without changing in the complete structure of the power plant, or without altering the complete system structure. Is it any way to save the energy or minimize the losses? And according to that, it has established Bureau of Energy Efficiency. So this body also keeps on like energy consumption patterns, and it is also created some norms or developed some standards for every appliances you buy, because if you see how much energy we are spending every day by different means, the means can be any appliances you are buying it from the market, from the domestic point of view. Even if you talk about the present transportation, like coming to the Bureau of Energy Efficiency, this will give you a norms, or it set some standards before releasing a product into the market. So there itself we have a star rating system, like 1 star, 2 star, 3 star, 4 star, depending upon the energy, how much energy it is saving for the same output. For example, you want to get some lightning output. We'll talk about lumens or intensity, light intensity. For example, you are buying a light equipment. Finally, it has to provide the lux or the light flux or light intensity. So what Bureau of Energy Efficiency stands for, or it states for the same amount of output, means you are not compromising the output of the product, how much power it will consume. For example, you want to get 400 lumens from a light. It is of output intensity 400 lumens. So to get the same lumens, how much a particular 1 star equipment will consume the energy, To get the same output, how much a 5-star appliance will utilize the energy. This is called the star rating. So here we are not compromising the output. So finally, the star rating can be, just now I said, CFL means the chlorofluorescent lamps and even the geysers and refrigerators, whatever the appliances you are buying in day to day. So these are all having the ratings. So based on that, anyhow, the cost analysis is also matter here. Right. And again, there are some amendments to the bill. If you see this slide here, there are some amendments recently. If you see, it has made, the bill has been approved recently. It is 3rd August 2022, 3-4 months back. So the Energy Conservation Act has been made in 2001, and the center has amended recently. What is the amendment is that it is coming under Energy Conservation Act only. Carbon credit trading scheme. So first of all, what is this carbon credit trading scheme and how it is having impact on energy conservation? That act says that, what the act says that some designated consumers. What are the designated consumers? Generally, this act is not talking about domestic consumers. Domestic consumers in the sense those we consume 5 kilowatt, 10 kilowatt, less than very I can say low load consumers. So designated consumers here in this sense, it is 100, more than 100 kilowatt. Those who are consuming the power more than 100 kilowatt. So the designated consumers may be required to meet a proportion of their energy needs from non-fossil sources. And not only that, so the commercial buildings and residential buildings which are connected to 100 kilowatt and above, they have to go for this carbon trading scheme. They must go for carbon trading scheme. So first of all, what is this? Even for example, the transportation ships and even the specified vehicles, they should follow some energy consumption standards. If they were not following that, so they have to go for a carbon credit trading scheme. So what is the trading scheme? It aims to reduce the carbon emission. And what is the what are the targets here? That we need to reduce the carbon emissions almost like 1 billion tons by 2030. So these are the targets for this amendment, like the 2022 Act. So based on that target, these things have been made. So anyhow, the carbon trading scheme, I'm not going, like I can directly go to energy conservation innovation techniques. Okay, so not only that, there are some other targets also. Like India is almost, it is trying to move to installation of 500 gigawatt of renewable energy by 2030, and it is also keeping some primary activities in transportation and mining and manufacturing, such that wherever the possible ways to conserve the energy. So there, this Act 20, this energy policy will talk about all these points, like where we can possible implementation is like possible conservation can be done, such that it should have a less impact on the environment, as well as it should have long sustainability. Okay, so first of all, what are the objectives of energy conservation or objectives of energy management? First of all, resource conservation, the first thing. And the second thing, climate protection. Just now I talk about CO2 emission, CO2 emission standards, or I can say carbon neutrality. Carbon neutrality or carbon trade-off. Actually, it's talk about CO2 emissions. We have to reduce the CO2 emissions. That is also target of our energy management, in addition to the conservation. And finally, we will look about the how much cost savings we will do by this energy conservation techniques or innovative techniques. Right. So first of all, my complete thing will be talking about a user level. In user level or day-to-day life, what an user can able to do, like I'm talking about domestic level, or I can say the end user level. End user level, if you, because anyhow industries and industries point of view, they will be like has to compile with the Indian standards if they want to sell their product. Obviously, the industries who are what are all getting their products output, like they have to follow the Indian standards, and then only they can able to sell the product into the market. So obviously, they have to compile with the energy standards. But coming to the, I can say unorganized group, or I can say the common man, like generally the common people, we are also the source of carbon emission. Like even every user is a source of carbon emission. How every user will be a source of carbon emission? For example, I am in the room, I'll be switching on my light. I am in the room, I'm switching on my air condition. Means I am emitting the carbons into the atmosphere by switching on the air condition. But if I want to make it zero, like carbon emissions into zero, I have to switch off my AC. That is the only option. But still there is an option, you can switch on the AC and still you want to make your carbon emissions zero. So how you can able to do carbon emission zero? By getting your comfort or by getting your application done. So that is what a common man point of view, every human being or every person is a source of CO2, or I can say source of carbon emission. Not only I'm talking about the air we are taking out, it is about your everyday application, everyday what we are using every day-to-day life. I am talking about from air condition point of view, talking about a vehicle, you are driving a four-wheeler or two-wheeler. So we are releasing some carbons into the system. So we are all going for this carbon emission. So that's why my innovative practices I included into the day-to-day life. So what day-to-day life practices we should do? That too, what actually in the market they are available in the market, and some are in the research level, such that it will make your carbon emissions, I can say from you it is zero. Like even though you are trying to consuming or delivering or emitting some carbon emissions into the atmosphere, at the same time you are also absorbing the carbon emissions from the, what is the carbon neutrality? Carbon neutrality in the sense how much you are generating into the atmosphere and how much you are absorbing from the atmosphere. So even if you absorb from the atmosphere, that is also like generation is equal to absorption. It is said to be that carbon neutrality has been achieved. So anyhow, energy management, one of the objectives is carbon neutrality, and in addition to the energy conservation. And even if you go for any carbon neutrality objectives, the carbon neutrality objectives, they also actually fill the goal of energy conservation. We'll see that. First of all, the need to practice, it is net zero energy building concept. So what is this net zero energy building concept? If you see that diagram here, so we have, for example, we have a house here. So what we need to do, like we are trying to get the zero energy building concept means.
Excuse me, sir. Diagram is not visible, sir.
1 minute, ma'am. Is it not visible?
Not visible, sir.
Is it visible now?
Oh, now, sir. Visible, sir. Sorry, sir. Yes, sir.
So can I maximize it or no? I think if I maximize it is not visible. Now it is visible? No.
Visible, sir. Visible, sir.
Okay.
Yes, sir.
Okay. All right. Coming to the zero energy building concept, here what we are trying to do, that whatever the energy we are consuming in a building, we are trying to generate the same energy by alternative sources, and finally we are not depending, like to consume that energy, we are not depending upon any fossil fuel based techniques, as well as we are not depending upon any utility or electricity grid, or you are not depending upon any electricity board to get your power, I can say your power demand. So for example, the building is having like it needs some ventilation concept, it needs some cooling concept, like we need cooling in the summer, and we need heating effect in the winter, and we need ventilation during at least at the daytime if it is official commercial building, and we need maybe the water heating system, and we need 24/7 power supply to meet all these demands. So how we can able to do, if you see this complete zero building concept, so we are going the roof insulation, we are going for wall insulation, and we are going for some renewable energy system and a solar thermal system, and we are going for energy efficient appliances. Anyhow, it's because here I'm not talking about cost of the system, because if you go for zero energy building, obviously the cost of the system will be more than actually what you are spending the normal system, normal building. Zero energy building system obviously is a costly, but how we are going zero energy building means the energy demand of the system we are generating there only, and we are consuming there. Finally, it is achieving the net neutral energy generation and consumption, like from the outside. The building is a self-sustained building. Right. So this obviously it will have impact on energy generation, because you are not depending upon the fossil fuel thing. So you are not taking any electricity from the grid. So you are not depending on any thermal power station which is generating the energy. And obviously we are not contributing any CO2 emission to the climate, and obviously it is helpful to the ecology. So this is one innovative practice. Still, like the people are doing it now. They are saying green building, they are saying clean building, and even it is that I can say maybe still it is not coming to the end user level, but in the R&D level, and still some major MNCs, they are doing this zero energy building concept. Even Microsoft has set the target. Microsoft, if you see, by 2050 they set a target that they established in 1970, Microsoft, and by what their pledge or their commitment is that by 2050, whatever the carbon, I can say CO2 emissions they have done from 1970, whatever the CO2 emissions has done to the environment from 1970, so they want to neutralize that CO2 emissions, whatever they emitted from 1970 to present now, whatever the emissions they have done, they want to compensate it by 2050. Means they want to absorb the CO2, or they want to absorb their carbon emissions by going with different techniques or technologies, such that by 2050, whatever they emitted into the environment, they want to take it back, or they want to absorb it back. This is called carbon trading. So that is actually Microsoft has come with some technologies and innovation techniques, how they will be doing. In that, one is zero energy building concept, and they are now depending, I mean, they are getting their things from renewable sources, and they have the carbon credit concept. They'll calculate the carbon credits, and finally they want to achieve the target by 2050. Right. So coming to the building energy concept in India, you see that it's a different states I have given for references, like how building energy consumption is increasing. It is the gross average. It is a cumulative average from past 15 years. I have taken around 1 decade data, and it's from sources I have taken residential electricity consumption, how it is increasing for each state from almost 2% to 2004 to almost it is 12% from each state, how the residential electricity consumption is increasing. Out of all the electricity consumption, how they, like, it's almost now, if you see cumulative average, it is 16%. So 16% of the energy we are going to the building only, and that in that 16% we are spending on the, I'm saying end user point of view, or I'm talking about the unorganized group. What we are talking about, domestic user, it's unorganized group. So generally they will not come under all these policies. For example, they are consuming 1 kilowatt or 2 kilowatt, they will not come under this actually the big consumer policies. So but still there is a lot of scope here to conserve the energy, but how it can be done. So these are all some have taken some initiatives has taken by the US government, and we are also trying to follow that. So what are the initiatives in the mainly the building commercial building level? So what they want to do that by 2040, like ZEB means zero energy building, like what are the commercial buildings exist now, by 2040 they have to make all the buildings as zero energy buildings. How they can able to do that? Zero energy building means they have to go for, so this is the typical layout. If you see the diagram here, how they can able to go for zero energy building. First of all their daily energy consumption needs, they are going by different sources. It can be a battery, it can be a solar, it can be wind, or it can be any other source. And one more thing, that they are, instead of AC, actually they are going for a DC thing, and they are not going for like any AC loads. All are the DC loads. These are all typical example how we can go for a zero energy building, mainly in terms of your power consumption, or I can say electricity usage from the utility. Because if every building, because once the building has been constructed, and if you see the daily maintenance of the building, if you talk about commercial buildings, mainly the commercial buildings, so majority of the energy around there, for example, for heating and cooling and lighting, so they're spending all the energy, they're consuming power electricity from the grid to meet these loads only, like lightning loads or HVAC loads, or I can say your maybe the data centers. So what are the solutions here to meet energy conservation targets? We have some energy conservation targets, and how to meet that. First of all, you have to switching over to renewable energy source. That is one way to meet our energy conservation techniques. And other way is, like obviously I told that how to do conservation targets. we have to switch over to energy efficient technologies. So some are free of cost, some energy efficient techniques. I'll show you that which are free of cost, like utilizing the solar resources and which utilizing the wind resources. They're all energy efficient techniques as well as free of cost. And some are costly, like you have to go for some alternate. Even though they are costly, the payback period will be very less compared to their lifetime. So even though they are costly, you have to go for some energy efficient techniques. And how to meet energy conservation targets by developing some carbon neutral environment. So carbon neutral environment, just now I told that how to do the carbon neutral environment, and how you can done by conducting energy auditing studies. For example, already it is a constructed commercial building. Then you have to go for energy auditing studies, or it is a old building, or it's a old industry. You have to do energy auditing studies, and you have to identify the sources of losses. Here we'll say in energy auditing, the first point is that you have to identify the sources. What are the sources of losses? So then you have to minimize the source of losses. This is also your energy conservation target, like you can meet. And finally, we should have a strong policies and implementation of the policies to meet these targets. Now let me go to some application here, like energy conservation targets. How we met, like we have taken or how we are implementing this energy conservation targets in day-to-day life. So for that, we have taken a case study of NIT Tiruchirappalli only. We have taken a case study and we try to implement these things like energy auditing studies and finding out the sources of losses, and anyhow developing the carbon neutral environment by it is possible by going to renewable energy sources, switching over, and we try to switching over to energy efficient technologies also. What are the possible ways? So energy conservation is applied to a building, like we have taken a building case study, and there we have, and the same analysis can be extended to any application. So that's why we can generalize it, the analysis, but it is a simple case study for a building. So first of all, if you take a building, like what are the different types of loads we have? Like we have, for example, we have academic building, or we have a residential building here. So we have thermal loads and we have electrical loads, and we have because even though it is air condition or fan or your lights, they're all coming under electrical loads, and your direct, like your water heating output is thermal load, right? It's a thermal output. So what we are depending on here, like we have energy sources from solar and grid. So we are taking power from like one is from green energy and other one is from the grid, right? So what are the different type of loads here? Like we have lights and fans and electronics, TVs and computers, and heating loads and heaters and cooking, and maybe for cooling effect we have a refrigerator and water pump. These are all like any if you take these loads, it's very common if you go for any household application. These are all loads are very common. So what are the efficiency analysis? If you use solar thermal energy, because my output is solar, I need some, I can say the hot water for application. So if you go for solar thermal energy directly, instead of converting electrical energy to thermal energy, directly you can use thermal energy. It's a good efficiency technique, like how you can do it. Thermal to thermal, like you no need to go for electrical to thermal application. So one more thing, like if you have electrical load, again, instead of depending on the grid, you can go for solar PV with storage, without storage. Then we have one more option, grid to electrical load. It is also efficient, but if you see grid to thermal, it is not efficient, because grid to thermal means it is having so much of loss. If you go for a geyser or I can say the heater, it will have so much of losses, and it is not efficient technique. So it is very well known thing, like what we have seen, we'll see a case study that without solar generator we have done a case study, and how anyhow we all know that how it will work, like thermosiphon system and technique. The principle is thermosiphon technique, and the solar water heater, we are not doing anything, like we are trying to extract the radiation availability at our location, and we are storing that water, and whenever the water requirement is there, we are trying to utilize the source instead of depending upon the grid. We are not depending on the grid, or we are not utilizing any electricity which is developed by the or which is taken from the grid. So directly we are depending upon the water heater. So one more thing, natural lighting, we are not going for any lights or tubes. We have one more option, it's a free of cost, like how the sun pipes. The sun pipes, it is like we'll have a, if you see the structure here, we'll have a reflection structure here. If you see, it will have multiple reflections. Finally, there is the sunlight has been transferred to your home. And the technique here is that it should only allow the, I can say, visible radiation. It should only allow the visible radiation such that your room should not get heated. Because if you try to open this opening, you are allowing directly the radiation into the space or into your working space or your home space. It will, in addition to the ventilation, you will also get some temperature. But for example, in the summer, you actually, your room should be in the cool condition, but similarly you have to get the ventilation. So what we need to do, we will allow the trappings here, we will allow all other, I can say, we will allow only visible radiation. We will trap all other radiation in the solar spectrum, and we are allowing that into the space. It will be all during at least working hours. For example, commercial buildings and office buildings, night time there is no working, and we have only morning 8 to evening 6 or 5. That time we have available of radiation, so we can go for daylight saving. The concept is called daylight saving, and instead of not only that, daylight saving, and in addition to sun pipes, we no need to go for any extra lighting effect, because we will get the same eye comfort of, I can say, 400 to 600 lumens. You can get the intensity. You don't need to switch on your normal lights. I can say your normal fluorescent lights. Right. So this is one natural lighting. It is one technique we can use for zero cost. Like you don't need to spend any money here, other than keeping a mirror. I can see if you go for different type of glasses, which will only allow the UV and which will not allow the other radiations like infrared radiation. For example, how we can design by using wavelength, because if you see the wavelength, based on that you can design. For example, if I allow only 400 nanometer spectrum to 700 nanometer, I can allow only visible radiation, then obviously it will create that lightning effect. This is one innovative technique. So other innovation practice that we are going back to our olden days, like DC, like we are not at all talking about AC. For example, if you see all over, if you have a water pump in our home, like if you have a water pump in agriculture, they're all induction motors. And if you have a fan, ceiling fan, like all are now AC applications are there, and some DC applications are also there, like your laptop and your mobile phone chargers. And if you have electronic appliances, they're all come under DC appliances. Instead of going some are DC and some are AC, we are going all with DC only. Like we are not going anything about AC. So what was the advantage of it here? Like we have a air condition, so we have a compressor there. So what we will try to do, we'll try to go for some type of techniques here, even for our lighting, even for our pumping, water pumping, even for our any electrical application we are using it, we are directly going to DC. We are not going for AC. So what is the other innovative? Just now we talk about LED instead of your normal fluorescent. So LED compared to your normal fluorescent will only consume, I can say, at least 1/5 times to 1/10 times of normal your CFL bulb will consume. So even the smart LED, even LED already we are started installing, but now we are talking about smart LED. Smart LED means it's like we have a I can say the sensor, or we have to see that whenever the light is needed in that room, it will be on. Whenever the light is not needed, it will be off. It is a smart, it will follow some instructions, and based on that, the light will on and light will off, which will also some energy conservation technique. Even the brightness, how you are adjusting your mobile phone brightness. You will go for 10% brightening to 100% brightening, how you are adjusting. The same way it is possible for LED also. For example, you need some bright light, so you can go for adjustment. So this is one smart technology. Now it is available in the markets also. And one more technology, it is BLDC technology. So those who are non-core from electrical, like BLDC means we'll talk about brushless DC technology, because we already mentioned, like we have induction motors. Generally, they're all less efficient. They'll be operating at less than 50% efficiency. If it is three-phase, if you go for, we'll go 70% efficiency. And if it is single-phase, we have very poor efficiency. But all our, I can say the domestic applications, we are all having in the refrigerator, we have single-phase induction motor. And there are less efficient motors. So what we can able to, or how we can save the energy instead of less efficient motors, we can replace with high efficient motors. They're all BLDC motors. If you see the analysis here, they will consume only 1/3 of the efficiency, like I can say the power, like they'll consume, for example, on every condition, I'm saying that your output will not change, or output should not change. For example, I want to run a motor for fill a tank for 1 hour. I want to fill a 1,000-liter tank, for example. That is my output, right? I should not sacrifice. I should not compromise in the output to do the same work done. How much energy it will consume? It is only 1/3 of I can say compared to the induction type of motors. So this is one innovative practice, and now it is also into the market. Still, they are somewhat costly, but still they are implementing now in the energy efficient techniques or innovative practices to save energy, to conserve energy. And one more thing, that home energy management. Now people are talking about home energy management, and people are talking about smart metering and smart grid. So how they are doing it, like they have to go for, I can say that wherever there is a no need of energy, or I can say there is a high cost of electricity price, that time we'll try to decrease our power consumption. Wherever there is a low cost of energy, I can say energy means per unit price. Whenever there is a low cost of energy, you will try to utilize the energy. So this is called somewhat energy management. So we are shifting our loads according to the price. So anyhow, this has to be done from the utility point of view, or I can say utility means electricity board point of view. They have to, still they are doing it in India in the pilot type. They are doing it. For example, you will get some information 1 day before that this is the price pattern. So based on that, you will plan your your loads accordingly. You can switch on the loads, non-peak hours. In the peak hours, you will switch off your loads such that the load can be balanced. And again, I can say you can effectively utilize what are the power generated from the grid or from the power plants. So this is called smart energy management, or I can say it's called load management techniques or scheduling of the loads. Okay, these are the case studies we have done. I'll simply or quickly show you that how we have done. It's very simple calculation as a case study we have done. For one application we have done, like what are the different types, like we have CFL lamp, fan, fridge, motor, pump, TV. These are all applications like any home load applications. So what are the power ratings we have? Different power ratings like 40 watt, 80 watt, and fridge and motor pump. And we have taken quantity, like how many are there, and we have taken time of hours, like 6 hours, 12 hours. So finally, we calculated energy consumption for each equipment, how much energy has been consumed for each equipment. Then we have, if you see here, the last amount here, if you see total energy consumed here, 546 kilowatt hour for a typical power consumption with the convention home with AC loads with electric heater. This is what electric heater here, right? Right. So it is how many units? It is almost 546 kilowatt hour of energy we are consuming for a typical application. So what we have done, we have simply gone for one small change here. So and we had done the calculation analysis from, like we have taken the Tamil Nadu Electricity Board price slabs we have taken, and we have calculated like 0 to units consumption here. If you see the scheme, and they are available in online, you can, if you want, you can see. But we have taken this, like what how many units are we are consuming, and what is the unit per unit cost you have to pay. So based on that we have taken, and the total electricity bill we taken, it's almost 2,000 rupees cost, 2,100 rupees total cost, right? For one, I can say we have done this analysis, right? If I go for some energy conserving techniques, energy conservation technique, instead of electric heater, we have taken one small solar water heater. It is almost, we have taken some Honeywell, it is almost 10,000 rupees cost we have taken, and we install it. So after that, if you do for 1 month analysis, and the same house application, we have not changed anything other than this, I can say other than this electric heater. All the loads we kept as it is. We have not gone to DC. We have not changed the motor pump. We have not changed the fridge or fan. Nothing we have changed. We have changed only the electric heater. So this is how a small energy conservation technique will see that. So how many units it is? It is now solar heater. We have installed it. So the cost, the units consumed is 0. So previously it is 546 units. Now it is almost 486 kilowatt hour. So this much energy has been consumed. Now we have done the cost analysis, and we have taken 5-year warranty and 10,000 rupees cost. We divided it, and it came almost 1,256 rupees per month. So previously it was almost, even if you do per day analysis or per month analysis, it's up to us. So previously it is 2000, almost 2100. Now it is almost 1200. See, one small electric heater, like if you replace with your normal solar heater, how much cost change it is, even after including the payback period, also. This is what a small energy efficient technique can save the energy as well as the cost analysis. Similarly, now we have one more case study that what we have done, we included all innovative practices. Like what, even though here we have not done cost analysis directly, but what we have done, that first of all we have taken what are the possible replacements possible. For example, here we have LED light replacement possible instead of fluorescent lamp. It is only 20 watt. So fan we have taken, if you see here, fan it is almost 80 watt. So here we have taken sophisticated, like I can see the DC fan or a BLDC. Here it is only 35 watt. Then I have taken fridge, which will also DC. Directly I moved to 23 watt. Then motor pump, it is 370 watt. So like that, here I have try to implement all DC loads which are innovative, which are all currently marketly, I can say current market, they are all available. We are talking about they are all commercial level. It's not in R&D level. So then we have done this as a case study, a research objective, and we identified the total power consumption is 153 kilowatt hour. If you see the change here, 486 and 153. So almost how much it is? Almost 1/3. My power consumption has been decreased. Totally 1/3 of the actual power consumption. If you compare with original power consumption, it is almost 1/4 times. So here we have not talked about the fixed cost, like installation cost we have not discussed about, because if you talk about installation cost and if you talk about all other costs also, you will, because here if you do the analysis here, we are getting almost 100 rupees per day. Because fixed charges, if you talk here, we have not included your payback period of all the appliances. But if you replace, I am saying that you are replacing everything with innovative technologies, but which is not possible because they are all not cost effective. And the government has to go for a policy level to implement all this. For example, if I talk about the motor pump, who will talk about BLDC motor, fridge, and even the air condition, if you go for, they're going for a compressor to run a BLDC motor, they are using it. And even for fan also. So, but generally they're all very costly and like it's not possible. I'm talking about the installation point of view, but we have to do the complete payback analysis, and government also needs some policies such that the initial investment cost can be decreased as much as possible. But in that case, you need to pay only out of 2000 rupees there, we need to pay only 100 rupees hardly. Because we have talked about consumer point of view, you need to pay only 100 rupees. If you see as a consumer, instead of paying 2000 rupees, if you pay 100 rupees, if you leave about the initial cost, then how much actually you will be saving in terms of money, as well as obviously energy also, because energy conservation techniques always, I already told you that there are some free of cost. If you want to play some innovative techniques like your water, I can say your solar lighting, it's a free of cost, but some are costly like your energy efficient techniques. Okay, so this is what we have done the analysis, and because this topic, the overall attending the session, so this should be like what the small changes will help you to conserve energy. And if you see, we have not done big things because these are all already mentioned you that the day-to-day life you have to implement these things, and if you do these things in day-to-day life, how much actually the savings almost 50%, and this is not only the savings I said, even if you want, you can able to do energy savings also. How much energy you can able to save here? I said almost you are saving 60 to 70 kilowatt hour of energy you are saving in terms of energy point of view. And if you talk about case 3, if you leave about the cost analysis, energy saving point of view or energy conserving point of view, you are almost saving almost 180 to 190 kilowatt hour of energy. You are not depending on the grid. Means almost you don't need to take this much amount of power from the grid, and obviously the grid, if you are not taking from, obviously the fossil fuel power consumption will be decreasing. So this is some comparative analysis, like how the things can be done by small analysis. And if time permits, maybe for 5 minutes, I'll take one more case study we have done. Again, this is also energy conservation techniques. We have given as a pilot project, like how we are doing in Anadagirichi for small building application. Again, it's a pilot project. What we have done, we have simply taken a drinking water cooler, and these are all very common, like what is the non-working time and working time. Actually, the cooler will be switched on every time. If you see in your home, the refrigerator will be switched on every time, even though if you use or not, night time also switch on, it will be in on condition, and how much power it will be consuming, and how much power we need to, sorry, how much we need to pay the bill. Not only that, how much energy we are getting wasted. So we have done small analysis here that this refrigerator having both cooling output, I can say cold water output and the hot water output. If you see the hot water will switch on, we have a sensor inside, and the design is like that. Every 1 hour, even though if you won't use the if you won't consume the hot water also from the fridge, it will switch on for 6 minutes only. Like the heater inside the thing, it will switch on every 6 minutes. Remaining 54 minutes, it will not switch on. But still, how much energy you are losing? And anyhow, the compressor load is on every time. The compressor load is on every time. So we have done small analysis here. So what we have done, we use some energy analyzer. So this is the energy meter. So with this energy meter, we calculated what is the voltage for 24/7. What is the voltage we are applying? What is the compressor, the current it is drawing 24/7? And what is the power calculation? It is almost 345 watt. It is on all time. So if you see the units consumed, it is almost 165 kilowatt hour. So if you take only the heater, then it is almost consuming, if you see, because remaining calculations I am not explaining, it is okay. It is consuming 48 kilowatt hour energy. So total we are consuming, I can say this 165 to 40, I can say roughly 210 kilowatt hour. So 210 kilowatt hour energy, and actually we are paying because if you are crossing the limit, so we are, for example, we are paying commercial usage. If it is commercial building, if you are paying 12 rupees cost, because if you increase the slab, right, your slab rate will change, and you have to pay 7 rupees to 12 rupees depending upon your slab. So type of consumer. So for example, you are paying 12 rupees per unit. Complete institute we have some 50 units, right? If you total we are have the cost analysis, we are almost spending almost, or I can say we are almost wasting 1 lakh per month. If you do this thing simple analysis, we are observing that total we are losing 1 lakh for simply the compressor, or sorry, the air cooler, whatever the fridge we are using in our colleges or academic blocks to dispense hot water and cold water. If we have some 20 or 10-15 departments, and each department we have 2-3 coolers also, so approximately we are losing more than 1 lakh depending upon this lab. So here also we have even energy conservation is possible, and we are trying to, here also we are trying to go for some innovative techniques such that the on time can be decreased. And again, is it possible to decrease the compressor power consumption still less than 345 watt, such that my energy consumption can be decreased, as well as my electricity bill also, end user point of view, the electricity bill you paid also will be decreased, as well as the overall savings will be increased. So finally, how we can able to conserve the energy. If you see my complete lecture, there all be focus on your domestic application point of view, and I am saying about the analysis will be applied because we have done small energy auditing study for what are the loads we have. Similar, because as we are all academic buildings, and as well as you have R&D also, research we are doing on this energy conservation techniques and how the smart technologies, even if we are thinking about integrating the IoT, because generally in energy conservation we have 3 aspects to address. The first aspect is actually will not talk about cost. We'll talk about only how much the energy we are saving. We are not talking about the cost, as well as we are not compromising the output. That is the one case study. Other case studies, like sometimes you have to compromise the output, means you have to switch on the loads. You have to go for load management, means you are compromising the application. Like we are not, for example, we are postponing your energy utilization time. For example, you want to utilize the energy now, but you will not utilize the energy, but you will utilize energy some other time. So here you are compromising your comfort. So this is the other way of doing energy conservation. Like in one way of conservation, we are not talking about the cost, Under any condition, we have to get the desired work done. Still, it should be energy efficient. So it will not talk about cost there. It will only talk about energy efficient technique. Other case, it will talk about cost as well as energy efficient technique by losing some comfort or by losing the work done. The next case, we have to do all the things, like we have to do work done, we have to talk about the minimum cost, then we have to talk about the thing. So this is called optimization. Like we have to do proper optimization. Means you have to go for energy efficient techniques, like losses has to be minimized as well as cost has to be minimized in the compared to the competitive market, as well as we have to talk about the total work done by the output. I can say the consumer need should be fulfilled. So this is the proper energy conservation technique or innovative technique. What is the proper energy conservation technique? Cost should be minimum, efficiency should be maximum, and finally the desired work has to be completed. So this is what your energy conservation technique target about, mainly I can say the domestic user or the end user. And finally, how you can go for like non-renewable energy sources, how we can decrease it, like we have to reduce the consumption, because finally we are going to the clean energy. In addition to the like how you have to save the energy, so first of all you have to minimize the non-renewable source of energy, like how we have done now, like we are reduce the consumption we have done previously, and we reuse manufactured products, and instead of going with that, we are recycling the products and we are reusing the products what are all available. Yes, and here I can end up my session, and if you have any queries on the present topic, you can ask me and I'll try to address it if it is in my zone. Thank you.
Thank you, Dr. Shiram Krishna.
Yes,
So I request the participants to give their questions. If any queries are there with respect to the presentation, you can put it directly to the speaker. Otherwise, you can put it in the chat box also.
Yes, sir, they can type it in chat box also.
Yes, doctor.
Dr. Shivaram, it's a very nice talk and also very informative talk regarding the energy conservation, sir. Sir, I have just not a question, but it is some clarification. So to convert into the complete DC motors and DC appliances in the home, how much the cost difference will come compared to the AC, sir?
Because sir, right now in the competitive market, we have to spend at least 2 times, sir.
Okay.
1.5, because now markets are like, for example, if you talk about electric vehicle. So if you try to buy electric vehicle, for example, you are spending 1 lakh to buy a normal motor vehicle. To give the same comfort and the same mileage, because you are not compromising about the mileage. Because if you go for electric vehicle, it may go for 100 kilometer. After that, again you have to change your battery, and again you have to go for recharge. That's why generally electrical vehicles nowadays, they are talking about low range. Low range means 50 kilometer to 60 kilometer. So the typical example here, if you talk about motor point of view, first I'll tell about electrical vehicle point of view, what we are seeing daily nowadays in the news, that almost they are all 1.5 to 1.7 times they are costly. I'm talking about the same power output. So the same thing is now true for motor application also. If you try to go for a DC motors, actually compared to AC motor, they are all very costly compared to DC. But if you still go for very high technology BLDC, and now they are all 1.5 to 1.7 times. You have to keep extra cost on that.
Okay, sir. So from this talk, sir, I understand that the energy auditing is very, very important, sir, even among all the common people, sir. And,
yes, sir.
Through the IEC, sir, we need to make an awareness. We actually plan to make a slogan, sir, and also we need to make an awareness about the energy auditing among the public, sir.
Yes, sir.
So, and yes, in IEC, there are so many energy auditors, sir, and they can prepare for this event, 7 days event, no, sir.
Okay, sir.
We can do some case studies like the energy auditing, and so after 1 year, then next year we can assess how much the energy because of the audit, how much reduce it, sir. Then we can make a report, no, sir, through the IEC. It's for the IEC president or IEC. So just suggestion, sir.
Thank you for your suggestion, sir. We will take it forward, sir.
Yes, yes.
Participants, any other questions? So if no other questions are there, we can go to vote of thanks.
Yes, sir. It's a wonderful presentation, sir. Thank you very much, sir, for your wonderful presentation. Now, I would request our Honorary Secretary, Mr. N. Sendil Kumar, sir, to propose the vote of thanks. Please, sir.
Yeah, thank you, madam. So at the outset, I thank all the participants for joining with us on this wonderful evening for this inaugural lecture as part of Energy Conservation Week on innovative practices in energy management. So I thank the speaker of the day, Dr. Shivakrishna Rao, for his wonderful presentation on the innovative practices in energy management. It was an eye-opening for all of us, so we could able to understand how the net zero building works, and we can able to knew about the solar bulb, smart LED techniques, which we can use at our workplaces and homes too. So next, the case studies, especially with respect to the DC load solar heater, and with the NIT developed case study for the water coolers, which is predominant across our workplaces, is very good. So hope all the participants would take the novice back into their institutions and workplaces. So thank you, Dr. Shivakrishna, for this wonderful presentation to all of us, and it was more eye-opener to us. So as part of Energy Conservation Week, we are going to have a slogan contest on energy conservation themes. One is on greener energy, and second is energy efficient India, in both English and Tamil, across 3 categories. The first category is for corporate members of Institution of Engineers linked to Salem Local Center, and second is for BTech and ME Tech students in the Salem Local Center jurisdiction area, and third is for MA MSc students across Salem, Namakkal, Dharmaburi, and Krishnagiri districts. So we request the participants to disseminate about the slogan contest across the institutions and the workplaces, and we will be shortly distributing, circulating the slogan contest brochure to all of you. So thank you all for joining us in this wonderful evening, and we request all the participants and their institutions and their organizations to take active part in this Energy Conservation Week celebrations. And we are going to have an validatory session on 14th December at Periyar University, Salem. So we request all the participants to join the validatory session of the Energy Conservation Week also. Thank you. So have a wonderful evening. Thank you all. So thank you, Dr. Shivakrishna, for joining with us today evening.
Thank you, sir.
Yeah, thank you. Thank you all.
Thank you, sir. Thanks to all, sir. Thank you so much.
Thank you all. And we thank all the professors who have joined from Periyar University for this session today. Thank you all.
Sir, our next session is directly on the validatory function, sir.
Yes, sir. So if any functions are lined up by the institutions, you can put it to us, and we can take it there, sir.
Okay, sir. Okay, sir.
Okay, sir. Thank you all, and we'll be communicating to you.
Okay, sir. Okay. Through this.
Thank you, sir. Thank you all. Yes, sir. Yes, sir. Thank you all. Thank you all.